All right. I'm going to work out a few problems from section 7.5, just as examples to help you study for your quiz. It covers 7.3, 7.4, 7.5. So here's a few problems from 7.5. So I'm going to try to do one type of each problem. Hopefully that'll help anybody who has any questions. So this is 7.5, number 34. So we're given cosine of alpha is the square root of 5 divided by 5. And we're given 0 is less than alpha is less than pi over 2. Also, we're given sine of beta equals -4 divided by 5. And we're given that pi over 2 is less than beta is less than 0. Negative pi over 2, sorry. Now, they want us to find our identities. And there's a part A, a part B, a part C, and a part D. I'll do part A and I'll do part D, okay, on the video. So part A says, find the sine of alpha plus beta. Now we know from our identities that that's sine alpha cosine of beta plus the sine of beta, the cosine of alpha. That's what we know the identity is. Now, for us to answer the question, then we have to find each of these four values. The way I like to do that is I like to represent this as a fill in the blank problem. So we have this. We have this number we have to find, this number we have to find, this number we have to find, and this number we have to find. Now, how are we going to find those numbers? Well, we already know what the cosine of alpha is. So we can put that number right here. They don't always give us this value in the problem, but in problem 34, they did. We already know what the sine of beta is. So we can put that right here. So we're left with having to find the sine of alpha and the cosine of beta. And the way we're going to do that is we're going to fall back on our what quadrant am I in? What is my reference angle strategy? How do I know what quadrant I'm in? Well, I look at my given, I draw my unit circle. I look at my given, I'm between 0 and pi over 2. So I'm in this quadrant, that's quadrant 1, so I'm going to write that down. Now, some of us are still struggling with how we find the reference angle when it's not a 30, 60, 90 triangle or a 45, 45, 90 triangle. So here's what we do. We say to ourselves, well, this is cosine. Cosine is adjacent divided by hypotenuse. So I label my adjacent as the square root of 5, and my hypotenuse has 5. I draw any right triangle I want to draw. There's nothing special about this right triangle. I know from right here, the hypotenuse is 5, so I'm going to put that right there. The adjacent side is the square root of 5. Now, the adjacent side is one of the two legs. It doesn't matter which leg you pick. It's not important. It's not that one's the square root of 5, but that one isn't. Or that one's the square root of 5, but that one's not. You honestly can label whichever leg you want to be the square root of 5. It doesn't matter. We can say this one's going to be the square root of 5. Okay, it doesn't change anything in the problem. You know one of the legs is the square root of 5. Pick one. Now, this side here, I need to know what this is, right? So we'll call this W, and we're going to do the Pythagorean theorem. The square root of 5 squared plus W squared equals 5 squared. So 5 plus w squared equals 25. That tells me that w squared equals 20. And if we take the square root of 20, we get 2 root 5. So that's w right there. So I found all 3 sides of my triangle. Now, which angle is going to be my reference angle? Some of us are still struggling with which of those angles is going to be the reference angle. Well, it tells us right here that the reference angle has an adjacent side of the square root of 5 and a hypotenuse of 5. So I look at either one of my acute angles, right? My choices are this one here or this one here. And I say to myself, the adjacent side has to be the square root of 5. Well, if I pick this angle, the adjacent side is 2 root 5. So that's not my angle. This is my reference angle. Because this is the angle that has an adjacent side of root 5 and a hypotenuse of 5. Now, we can fill in the sine of alpha. We have our triangle right there. The sine of this angle is 2 root 5 divided by 5. Positive because we're in quadrant 1. Now we're going to repeat those steps to find the cosine of beta. We're going to come to this part of the problem over here. We're going to write quadrant. We're going to write reference angle. They told us to find our quadrant. We're going to draw our unit circle. They told us that we're bigger than negative pi over 2 and smaller than 0. That means we're in this angle, this quadrant right here. That's quadrant 4. So I'm going to put quadrant 4 right there. All students take calculus. We're doing cosine. We're in quadrant 4. So this is going to be a positive number here. Now, what is the cosine of beta going to be? Well, to find that, I'm going to draw my triangle. Again, any right triangle will do. We know sine is opposite over hypotenuse. So our hypotenuse is 5. One of the legs has to be 4. So we just pick a leg. We just pick one. Maybe we pick this one. We call this one 4. We know this triangle. This leg is 3. Now, which of these 2 acute angles is going to be my reference angle? Well, it's the one that satisfies the condition that the opposite side is 4 and the hypotenuse is 5. So I look at this angle right here and I say, well, the opposite side here is 3. That's wrong. It's supposed to be the opposite side, it's supposed to be 4. So that means this angle turns out to be my reference angle. Now I need to know cosine of beta. Cosine is adjacent over hypotenuse. That's going to be 3 divided by 5. I already took care of the plus and the minus when I wrote down to this quadrant 4. Now to finish the problem, right, we go 2 times 3 is 6 square root of 5 over 25 minus negative times positive 4 square root of 5 over 25. And we're left with 2 square root of 5 over 25. So that's how we do problems when they ask us to find missing pieces of our identity, and all they give us is one trig value and a quadrant. All right. Another type of problem that we were given to work on was a problem where they gave us like problem 44, they said, well, let's do 42. I'll do 42 instead. In problem 42, they said g of alpha plus beta, but then in the problem they said g means cosine of alpha plus beta. Now we know what cosine of alpha plus beta means. Cosine of alpha plus beta means cosine of alpha, cosine of beta minus the sine of alpha, the sine of beta. And again, I like to think of this as being four blanks that we have to fill in. Now, how are we going to fill those in? Well, in problem 42, they give us a circle, and they draw alpha in the first quadrant. So they draw for us our reference angle, which in this case is alpha because it's in the first quadrant. So our reference angle is our angle. And they tell us this point right here is x comma 1, which means that side is x, that side is 1. And they tell us that our circle is x squared plus y squared equals 4. So that means our hypotenuse is 2. Now, we could use the Pythagorean theorem to find this side, or we could remember that this side is the square root of 3, because that's a 30, 60, 90 triangle. Now, we need the cosine of alpha. The cosine of alpha is opposite over hypotenuse? No, it's adjacent over hypotenuse. We're in the first quadrant, so that's going to be positive. Adjacent over hypotenuse is going to be square root of 3 divided by 2. I also need sine of alpha. We're in quadrant 1, so that's going to be positive. The sine of alpha is opposite over hypotenuse. That's 1 divided by 2. Now, I need to find cosine of beta and sine of beta. And they give me another circle. And on that circle, they draw beta in the fourth quadrant right here. So again, they've drawn for us our reference angle right there. The reference angle always goes to the nearest x-axis. This is beta, and we have our reference angle, and they told us this point is 1/3 comma y. And they told us this circle is x squared plus y squared equals 1. So the hypotenuse is 1. This side is 1/3. This side is y. Now we're going to have to use the Pythagorean theorem to find the other side. 1/3 squared plus y squared equals 1 squared. 1/9 plus y squared equals 1. Y squared equals 8/9, or y equals 2 root 2 divided by 3. Now we have to find the cosine of beta. All students take calculus. So cosine is going to be positive. We're in the fourth quadrant, so I'm going to put a plus right there. Cosine, this is my reference angle. Cosine is adjacent divided by hypotenuse. 1/3 divided by 1, 1/3. Sine is opposite divided by hypotenuse. 2 root 2 divided by 3. Now sine is going to be negative. We're in the fourth quadrant, so it's going to be negative 2 root 2 divided by 3. Now we multiply to get √3/6. Negative and a negative makes it positive, and we get 2√2/6. One of the other types of problems in section 7.5 are the questions where they ask us to do things like this, like number 78. They want us to find the cosine of the tangent of 5/12 minus the inverse sine, sorry, this is inverse tangent, minus the inverse sine of -3/5. Now we do this piece by piece. We look at the inverse tangent of 5/12, and we also look at the inverse sine of -3/5. Again, we're going to go quadrant, reference angle. Now, inverse tangent is defined in quadrant 1 or quadrant 4. We're positive, so we're in quadrant 1. Inverse sine is also defined in quadrant 1 or quadrant 4. We're negative, so we're in quadrant 4. So we know what quadrant we're in. Now we need our reference angle. To get our reference angle, we're going to draw a right triangle. We know tangent is opposite divided by adjacent. So these are both legs of my triangle, right? Opposite and adjacent, those are legs. There's no hypotenuse there. So one leg is 5, I'll make that the short one. The other leg is 12, I'll make that the long leg. Now that's a 5, 12, 13 triangle. We're supposed to know that triangle. Now we have to figure out which one is our reference angle. Our reference angle has to have an opposite side of 5. Well, if we try to make this one our reference angle, the opposite side is 5. If we try to make this one our reference angle, the opposite side is 12. So this is our reference angle right there. Now we don't know how big that is, right? We don't know how big that angle is. That's not one of the angles we know the measurement of. So I'm just going to name it, right? I can name it anything I want. So I'm going to call this angle alpha. So my reference angle, I'm going to write an alpha next to that, because I don't know the degrees. So I'm just going to write alpha. Over here, I'm going to again try to find my reference angle. I'm going to draw any old right triangle. Any right triangle will do. Sine is opposite over hypotenuse. So that's a leg. That's the hypotenuse. Hypotenuse is 5. One of my legs is 3. Now I know this triangle. It's a 3, 4, 5 triangle. So I'm going to make the small one 3, the long one 4. That way it looks correct. Now, how do I know which one is my reference angle? The reference angle has to have an opposite side of 3. So here's 3. So this has to be my reference angle. Now, I don't know how big that angle is. So I'm going to call it beta. So my reference angle is beta. So when I do this problem, I now have cosine. For tangent 5/12, tangent of 5/12, the angle for inverse tangent of 5/12, the angle I got is alpha. For inverse sine of -3/5, the angle I got was beta. Now I'm left with an identity that I know how to find. That's cosine alpha, cosine beta minus sine alpha, sine beta. And again, I do this by thinking about this as being fill in the blanks. Now we have angle alpha and angle beta drawn for us on the whiteboard. Angle alpha is right there. Angle beta is right there. We have triangles for those. If I need the cosine of alpha, I'm in quadrant 1, so I put a plus. Cosine is going to be 12 adjacent divided by 13. I need cosine of beta. Beta is right here. Beta is in quadrant 4. Beta is in quadrant 4. In quadrant 4, cosine is again positive, so I'm going to put a plus. Cosine of beta. Cosine of beta. So cosine is adjacent over hypotenuse. That's 4 over 5. Now I need sine of alpha. Alpha is back over here. Alpha is in quadrant 1, so I put a plus. Sine is opposite over hypotenuse. That's 5 over 13. Now I need sine of beta. Beta is in quadrant 4. That's going to be a negative. Sine's negative in quadrant 4. The sine of beta is opposite over hypotenuse. That's going to be 3 over 5. And now I do my arithmetic and I can finish my problem. 4 times 12 is 48. 5 times 13 is 65. I have a minus, a plus, and a minus, so I get a plus, and this turns out to be 15. 5 times 13 is still 65, so I get 63 divided by 65. These are exactly the same steps that we use to solve the problems in section 7.6. The problems in 7.6, and in particular, I'm talking about problems 7 through 18, all right, 7.6, 7 through 18, and 29 through 40. These are the same kind of problems I did in the first 2 examples on this video. We do those problems exactly like we did the first 2 problems on this video. So hopefully these 3 problems help you with your homework and help you get ready for the quiz.